Good morning, everyone. Welcome to the workshop on integrated ecosystem experiments to advance Earth system predictability. My name is Anthony Walker, and I want to thank you all for being here today. It's really appreciated. No one needs another virtual meeting. I understand that. We've been to many virtual meetings in the past couple of years, so I really appreciate your input and your time. Thank you very much to our speakers for pre-recording talks ahead of time. I know it's not easy, and no one likes to hear themselves back recorded. Thank you everyone who filled the pre-meeting questionnaire and our breakout facilitators for taking up the mantle there. Thank you to our organizing team. It's a real team effort. Colleen Iverson, Matt Craig, Verity Salmon, thank you very much, you guys. And our admin support, Melissa Clark. Thank you, Melissa. Please direct any website questions or suggestions you might have to Matt Craig, and he will be able to update the website on the fly with any requests or suggestions. And thank you very much to DOE for our funding support and some support for this meeting. First out, I want to start with our code of conduct, which we've borrowed from AGU meeting code of conduct. Please check that out. Our goal here is to foster an inclusive and creative dialogue. So please communicate openly, listen well, and be considerate of the views and opinions different from your own. Treat everybody with respect, critique ideas and not people. Be mindful of your surroundings and your fellow participants. Consider the effect of power differentials so that we can try and avoid dominance in discussions. Respect the copying use of presented materials. These are just agreed to be used at the meeting so far. And be accountable and hold us accountable. If we deviate from this code, please let us know and we'll work to remedy the situation. So the workshop background. Of course, as you all know, we're at a critical juncture in history, both human history and global history, because humans are the globally dominant species, massively dominant, and that's coming with problems of global proportion. The recent IPCC reports are documenting some major pieces of those global problems. For example, this headline-grabbing quote from the Working Group 2 saying that human-induced climate change has caused widespread adverse impacts and related losses and damages to nature and people. And of course, DOE science has been a real leader in understanding some of these global problems. And our piece of DOE, the Earth and Environmental Science Division's mission, is to enhance the seasonal to multi-decadal predictability of the Earth system using long-term field experiments, DOE user facilities modeling, uncertainty characterization, best-in-class computing, process research, data analytics, and management to inform the development of advanced solutions to the nation's energy challenges, of which climate change is possibly the challenge. And it's this predictability of the Earth system, this predictive understanding of the Earth system that we need to develop and that we're furthering the development of, to really be able to understand the consequences of our actions and the consequences of solutions as they come around. So this is what we're working on, and this is what's motivated some of the title of our workshop, this Earth system predictability in this DOE mission here. And I just want to touch on a definition of predictability from this recent report from the National Academies. And you can see in the quote here, my interpretation of this quote is that predictability includes both the inherent predictability of a complex system that is an inherent property of that system and our current ability to predict that system. And so we can improve our ability to predict that system through improved knowledge, improved models, all of that sort of thing. So it's really this second piece of that we're focusing on in this workshop here, is this ability to predict the system. And ecosystem experiments, of course, are foundational to our knowledge of ecosystems and their responses to global change. They allow us to test hypotheses. Of course, that experiments are fundamental to testing hypotheses in the scientific method. They provide long-term, in situ, intact ecosystem responses that are often not possible to observe in pot or mesocosm studies. They have feedbacks that are not there in pot studies, or pot studies have feedbacks that are not there in ecosystems. They allow us to observe no analog environments, and they allow us to develop process understanding and knowledge that we can translate into our models. And they also allow us to evaluate our models too. And we want to extend this concept to integrated ecosystem experiments, which are outlined nicely in this 2008 paper by Lindsay Rustad. And that's the integration of experiments within a broader context of observations and knowledge So integrating experiments with observations across environmental gradients, and also, of course, integrating experiments with models, both pre and post experiment and during. And this really speaks to this DOE MODEX approach to doing science, this iterative wheel of model predictions, experiments, experiment results, model development, model evaluation, and this constant iterative wheel, which is akin to the scientific method tailored to our particular piece of science. And so going into some of the workshop goals now, our goal for this workshop is to scope the next stages of the ORNL TES SFA, which is a project, a terrestrial ecosystem science project, of which spruce is the lion's share of that project, the spruce experiment shown here. And so we want to scope the next stages of that project by identifying key Earth system predictability questions and experiments that can provide answer to those questions. So this is a scoping exercise. Spruce is currently scheduled to end in 2025. And there is some discussions around that, but spruce will end at some point. And so this is just the very beginning of that process to scope what might come after spruce. And fundamentally crucial to that process is development of community. And so this is the beginning of that process of developing community. And so in that order, we want you all to have fun. Hopefully this is an enjoyable workshop to think about what we might be able to do in the future. And so, as I said, this is part of ongoing discussions among and within existing vibrant communities. And there's lots of great literature produced by these communities on which to build. This is just an example list of some of those communities that we can borrow from. And I love this braided river analogy that describes number of pieces, or that's getting more attention in the literature to describe different things. I think it describes community very nicely. You have a broad community, but then there are sub-communities constantly forming and meeting back up again with other communities and reforming new communities. And so this is the beginning of forming one of those new communities. And this is some of the great literature that we have to build on. And all of these you can find in the meeting Google Drive. And this is a map put together by Paul Hansen, the PI of the spruce experiment, showing the collaborative institutions that collaborate on spruce and that help make spruce such a success. And Paul and DOE have done a great job of bringing this community together around the spruce experiment to make it as strong as possible. And so a bit more detailed overview about the workshop now. The structure of each day, we have 3 sessions per day, a plenary pre-recorded talk session for everybody to join, and then we have 2 identical breakout sessions at different times in the day to accommodate different time zones and different people's schedules. And so those breakouts are going to be identical each time, and I think you've just picked one of each of those. If you want to come to both, then please feel free. But we're going to cover identical topics on any given day with those breakouts. And I should say the pre-recorded talks, the idea of those is so that we can have Q&A during the actual talk, so that we can be a little bit more efficient with this shorter schedule that we have, given that we're virtual. So please ask questions during the talks, and the speakers can answer. And also it's helped facilitate a few people that can't join these plenary sessions view the talks before they join the breakout sessions. And so the daily topics and breakout charges. Day 1 is Earth system predictability and ecosystem experiments. Day 2 is press environmental change and ecosystem function. Day 3 is pulse environmental change and ecosystem structure. And of course, those are false dichotomies, but we've separated it out that way because we think it's a useful way to look at different angles of the problem. And I'll speak a little bit more to that in the next slide. And then on the 4th day, we're going to talk about integrated ecosystem experiments projects design. What elements of the projects, in addition to the experiment, do we need to make this experiment an integrated experiment and as valuable as possible? So on the first day, we want to identify key Earth system predictability goals, uncertainties, and poorly represented processes. On the 2nd day, priority questions and experiments related to press environmental change and ecosystem function and Earth system predictability needs. On the 4th day, priority question experiments related to pulse environmental change and ecosystem structure. And we can think about combining those two elements. and integrated. On the fourth day, we want to talk about these experiments. We're going to scope some experiments, and then on the final day, we're going to each break out into teams and work on one particular experiment and sketch out the details of what an integrated experiment around that question, that scientific question, would look like. And so here's a diagram of this, this pulse and press function and structure dichotomies or false dichotomies. They're more of a gradient, but they're an interesting way to break up the problem, and they're a way that the scientific community have looked at different elements of drivers and change and ecosystem properties. And so, yeah, I think this is a nice framing for the thinking about how we might manipulate an experiment and develop questions that that we can speak to and answer with an ecosystem scale experiment. And so I would argue that the majority of manipulation experiments to date have focused on manipulating press drivers of change and monitoring the ecosystem functional responses to that change. It's not exclusive, but it's primarily focused on press drivers of change. And you can see this figure from a paper that Paul and I put together. Paul put this figure together, just showing the mentions of experimental manipulations in GCB publications from 1995 to 2016. And you can see, note the difference in the scales of the y-axes there, that temperature, CO2, nutrients, and precipitation manipulations are the majority, but you can see disturbance experiments as a catch-all there are growing in citations or publications. So we focus primarily on press drivers of change, not exclusively, but primarily. But what we really care about, I think, in terms of impacts and global change and impacts on ecosystems is these structural changes to the ecosystem, long-term carbon gain or loss, biome transitions, permafrost thaw, just to name a few examples. And I think those are the really key pieces of ecosystem impacts that we care about, and where the majority of feedbacks are going to occur when we get structural changes to the ecosystem. And what's really nice is that we now have a model that really finely represents ecosystem structure, much more detailed than previous iterations of the model, this FATES model, which represents forest demography. And that's thanks to the efforts of Rosie Fisher, Charlie Coven, Ryan Knox, and many others. The NG Tropics Project, Nate McDowell was an early pioneer of supporting this work. And so we have this model now that can really finely represent ecosystem structure at site scales, but also regional and global scales as well. And so finally, as we think about ecosystem manipulations, although we've focused on press drivers of change, there are examples of press drivers of change manipulation or even direct structure manipulation. And we can manipulate all three of these quadrants in an ecosystem experiment. So let's keep that in mind. And so we obviously have some good examples of those pulse drivers of change experiments from Mendy Smith, Alan Knapp, Jeff Warren, and others here, and then direct manipulation of ecosystem structure as well with Chris Goff and some of the experiments that he's heading up. And so, yeah, let's think about this framework as we try and frame scientific questions and manipulations that might be able to answer those questions. And so can we envision combining more traditional press experiments with pulse and structure as well? And so here's a couple of questions that are dear to my heart. One is, how do carbon stocks in older, more mature forests respond to elevated CO2? I still think that's a major uncertainty. We don't have enough experiments in those areas, and yet there are observations, and the models all suggest that there is quite strong CO2 fertilization effect on mature forests. Majority of experiments have been done in younger forests in earlier successional stages, and there may be a gradient of responses across a successional gradient. And of course, the landscape is a patchwork of different successional stages. And so an experiment combining this press of CO2 with a structural gradient of successional stages would be, in my opinion, really useful and important experiment. And another question that combines structure and function, combines press and pulse would be, how does ecosystem function respond to the press of warming in interaction with hot, dry, or cold extreme events? Is tree mortality exacerbated when you have this press of warming and late season cold or dry extreme events? And this is kind of a temperate focus question, but it could be applied to the boreal, or it could be applied to more, could be modified to be applied to more arid regions and savanna type regions. And so this is not trying to presuppose the direction of the workshop. This is just giving some example questions that I think are interesting and important, but this is not presupposing the direction of the workshop at all. This is just throwing out some ideas and some example questions that combine these different elements of change and ecosystem properties. And finally, I just want to touch on ecosystem experiments, the integrated component, this kind of MODEX approach, where we have an ecosystem experiment at the core, but we have a whole suite of studies around that, model development and synthesis that informs the experiment, data assimilation to best understand our observations, targeted process experiments to understand mechanism within the experiments, observational gradient and process studies, again, to understand mechanisms and how ubiquitous they are, remote sensing studies to look at a landscape, the patchwork landscape that exists today, reviews and synthesis and meta-analysis, and then, of course, integrated model development and synthesis during the experiment and after the fact. And so this is what we want to think about on the fourth day. And so with that, thank you everybody for your time. Please be inclusive, critique ideas, not people. Looking forward to the workshop, and please enjoy yourselves. Thank you.